Hi there and welcome to this chemistry lesson. We're still looking at functional groups of organic chemistry. In the previous one we looked at the alkanes, alkenes, and the alkynes. Okay, and they are, each one of them represents a functional group, but together they are called the hydrocarbons. Why? Because they simply consist of hydrogen and carbon bonds. The hydrocarbons, hopefully you remember that the alkanes were saturated and the alkenes and alkynes were unsaturated hydrocarbons. Okay, and that's going to be the first group of functional groups we are looking at. In this one I want to look at two more groups. The first one are called the halo-alkanes. Okay, the halo-alkanes. Okay, so halo-alkane is an alkane. Okay, so it's got an alkane structure, which means it's got single carbon bonds. Alkane structure with at least one halogen substituent. Okay, substituent. Now, what do I mean when I say substituent? Substituent means I have replaced. Okay, this means replaced a hydrogen with another bond. Okay. So in other words, if I say I've got a halogen substituent, it means that one of the carbons on my structure, so it would look like this, the general structural formula will have alkane structures, which means we've got single bonds between our carbons. Okay, and then we've got our hydrogens bonding there. All of these would be hydrogens. Hydrogen, 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 but at least one of them will be a halogen. What is halogens again? They are the group 7. The group 7 elements. Okay, so let's go to our periodic table. Okay, do you remember the group 7 elements? They are these. Okay, fluorine, chlorine, bromine, and iodine. Okay, and we're only going to work with these 4, so don't worry about adenine and whatever that is. Okay, so only fluorine, chlorine, bromine, and iodine. So one of them can either be, this one can either be fluorine, chlorine, bromine, or iodine. Okay, and if it is, how will it affect the name? Well, it still has the suffix. The suffix, like a normal alkane, it will still have ane suffix, but it will have a prefix that is either fluoro, okay, if it is fluorine, chloro, if it is chlorine, bromo if it is bromine, and then we have iodo. Iodine is iodo as a prefix. Now, the reason why these compounds can actually make a stable bond with carbon is because all of them form part of in the periodic table of the group 7 elements, and all of them have one electrons short of filling up the highest energy level. And that's the same with hydrogen. Hydrogen just needs one more, so he's willing to share his one with someone else if he could have one more. The same here, because carbon has these 4 valence electrons, he can share one of them with one of these to fill up their valence electrons to the highest energy level. So that's why it works. And now just to show you an example of this, let's take 5 carbons. Okay, so we've got 5 carbons. Each one of these carbons will have 8 electrons in its highest energy level. Okay, so let's place the hydrogen bonds there, or the hydrogen covalent bonds there, and let's put a chlorine here. Okay, so we've got hydrogens all over. Now this one's name I will explain in a moment, but what it is called is 2-chloro pentane, sorry. 5 is pentane. Okay, now as you can see, we've got the alkane name here, pentane. This is for an alkane, the A and E at the end, but the pent represents 5 carbons. We know where the chloro comes from. That's because there's a chlorine substituent. Okay, and then but what about the 2? Where does this 2 come from? Well, in order to name compounds, we need to number the carbon chain, okay? Because this chlorine could have been on any one of the carbons, so we will name, and we will start on the side of the chain that's the closest to the substituent. So this would be number 1, 2, 3, 4, and 5. And so the 2 just tells me which carbon, what is the first carbon to have a chlorine, and obviously depending on from where I'm numbering, but the first carbon is the second one, that's called chlorine. And so this number will always be the smallest possible number. It could have been, if we numbered from this side, 2, 3, 4, it could have been 4 chloro, but that's not the convention. That will confuse people. So we just choose the substituent. We choose to number so that the substituent is the closest to the number 1 carbon. Okay, general formula. Well, we know that the general formula for hydrogen, for alkanes, are for every carbon there are 2 hydrogens plus 2 for the 2 at the end, but now it can't be plus 2 because one of the hydrogens have been replaced, so we must subtract 1. There's 2 plus 1. There we go. Sorry about that. And then halogens are usually represented with an X. Okay, so the X represents the halogen, and there could be more than one halogen, but for simplicity's sake, I'll keep it to this just to explain what functional groups is. So how will I recognize a halogen? Well, I will a haloalkane. I will recognize a carbon bonded at least once to a halogen, which is group 7 elements. Well, in the next video we'll look at some more functional groups, but that's it for now.